All you're hearing is your own. And I'm gone and you're all alone.
Okay, well, let's take a look here at Christina and her brand new Prius. Now, she just bought this car and she's so excited about it. She's been saving for a long time. And she's so excited that when she bought it, she's actually reading the owner's manual. Now, the owner's manual says that there's a break-in period because it's a brand new car. And they recommend that you take care of it during the break-in period very carefully. And so, they want you to change the oil after the first 1,000 miles. Then, after that, they say you can change the oil every 3,000 miles. So, let's go ahead and list the mileage odometer readings where she's going to need to change her oil. First, when it reaches 1,000. Then, we're going to add 3,000 to that. And she's going to have to change it again at 4,000. And then we're going to add 3,000 miles, and after she's driven another 3,000, we'll be at 7,000. She'll have to change it then, and then at 10,000, and at 13,000. And this is going to go on and on and on and on. Every 3,000 miles, we have a constant rate of addition here. Okay. Now, whenever that happens, when there's a constant difference, all these numbers are exactly 3,000 miles apart. When there's a constant difference, you get something called an arithmetic sequence. Okay? Constant change. All right? We have constant change over and over and over and over and over again. Now, in this case, the change is a sum. The numbers are getting larger as we go, and they are being added by 3,000. Okay? So, we've got a constant sum. It's also possible to create problems where you've got a constant difference, where you keep subtracting the same amount of number over and over and over. All right, well, let's make an arithmetic sequence. Let's describe it using a recursive formula. And the way we do that is to set up, let's see here, the first term. All right, so she's going to need to change her oil. I'm going to call that C sub 1 for the very first oil change at 1,000 miles. And then after that point, it's going to be described like this. No matter what term we're on, no matter which oil change we're on, it's always going to be whatever the mileage was on the previous oil change, C sub n minus 1 plus 3,000. Okay? And of course, this is for integers called n greater than or equal to 2. So these are the n stands for the number of oil change. So if we're on the second oil change, it would be C sub n minus 1, or this one right here, 1,000 plus 3,000, which gave us the 4,000. And so on and so on. Now, in general, okay, we say that the recursive formula for an arithmetic sequence looks like this. A sub 1 is going to equal some amount, some starting point. And then A sub n is going to always equal A sub n minus 1 plus your amount of difference. You know, how far apart are these individual terms in your sequence. And the D right here is going to always stand for your amount of difference. You know, how far apart are these? And they can also be a negative. All right, so we might be adding 3,000, we might be subtracting 50 each time. It might be getting smaller, it might be getting larger, but in each case we are adding, be it a positive or a negative, but some sort of difference there. All right, here's one more real quick example. Megan wants to take a trip to England. She's wanted to go all of her life. She's in her senior year. She finally gets an opportunity, but she still needs $500 to do it. So she asks her boyfriend Thad to lend her the money. Well, he loves her, so he says, oh, all right, but you got to pay me back. So she agrees that she will pay him back $50 each month, and since he loves her, he's not going to charge her interest. Can you believe it? All right, so we're going to let B sub n be her balance, okay, which means the amount owed after n payments. Well, let's describe this recursively. Okay, we'll draw our brace, because remember our recursive formula always has two parts, and the first part is always establishing your B sub 1. All right, so in this case, her balance after the first payment, okay, after the first payment, well, she owes him $500, she pays $50, so her balance after the first payment is $450. Okay? All right, and B sub n would be equal to the previous payment, the amount owed after the previous payment, which would be B sub n minus 1, and then we'll take off $50 more. So there you have it now. And one other little thing they love to mention is that your n are the number of payments here. So n is going to be an integer, and it's going to be greater than or equal to 2, okay? Because fractional answers and negative n's and so forth just don't make sense here. All right, one other thing to mention. In both of these examples, the one with the oil change in the car and also with the paying back the money, in every single case, we have a constant rate of change here. She keeps paying off $50 and $50 and $50 and $50. And here we keep adding 3,000 miles and 3,000 miles and 3,000 miles. So when we graph these, we will get a line. The slope on this line is going to go down, and the slope on this line, because the mileage, is going to go up like that. Okay, but you will get lines. They each start at a specific initial condition. In this case, the initial condition was 450, and it goes down. The other initial condition was 1,000, and it goes up. All right. So these are sometimes called linear sequences, as well as arithmetic sequences.
And all you're hearing is your own.